While we're on the topic of code, let's take a quick look as well at the equality and comparison that's going on within our solution for maps. So we mentioned a little bit about how we implement the equals method. Remember, the dot equals method is an override of something that exists in the object. And by default, the dot equals method points to the same thing as what the double equal sign does. It's this, is it the same object? And now you know about the hash code and how if I update the equals method, I should also always update the hash code. If you're not using a map, especially a hash map, you don't necessarily have to, but the better option is just go ahead and do it so that way I don't down the road say, oh yeah, I forgot about that, and it's not working funny like we saw before. So again, I can compare on anything as part of an object. We have our player object. What the answer is not important. Is it the first name? Is it the last name? Is it the number? That's up to the business context. What is the definition of what makes a unique object? The easiest answer is to assign a unique identifier. So with people, you could say social security number in the United States, but it's not guaranteed to be unique. Typically what you do is you create a customer ID or something when you sign them up into your system. And then you have a human go by and you get their name, address. You say, hey, are you this person? And if they say yes, then you update the old record. If they say no, then you work with the new record. But it's not super important. And in our example, the name may or may not be unique. The number plus team could be unique if I have the team information. It's something that we have to choose that we can go with. So how do you do hash code? Well, the equal method and the hash code method must match up. So the most simple way of doing that is if I'm using the player's number, I compare the player's number in the dot equals, as we can see here on the left-hand side, then all I have to do is use the hash code method from the number, the string, the date, whatever object that exists in Java, I can call that same hash code method and pass it along. Basically, I'm just kicking the can. The slight complexity comes in when I'm comparing more than one thing. So if I'm saying the number plus the last name is unique, because again, you look at the back of a jersey, whatever shows on the back of the jersey is going to be what makes a unique player on a team. So hey, that might be a good enough criteria. So I have to use those same values, number and last name, inside of my equals and my hash code, number and last value. Now in this case, what I'm using is a mathematical operation called the XOR. Again, it doesn't matter what the value is, as long as it's exactly the same value each time you do it. And so the XOR is a logical operator that takes the ones and zeros, and if they're both true, then it returns a false. This is detailed Java stuff, but it ensures that I won't have integer overflow. Because if I take two numbers and make them all 1, 1, 1, 1, 1, 1 using the AND operator or the OR operator, then it will basically end up with a very low, uncommon set of numbers. The XOR is a mathematical trick around making this happen. Now, it's not the only implementation. I've seen other implementations, and if you generate code from NetBeans or Eclipse, you'll see other implementations. There's other math operations I can do along the lines to get the same results. Really, the number doesn't matter so long as it somewhat pseudo-randomly splits up objects across the different hash buckets, if you will, that is going to be in a hash map or a hash set. So this is a little bit of the implementation of hash code. Now, along the question of comparison, what does it mean for one object to be greater than another object? I mean, with players, which one's more famous, which team has more wins, which player has more stats, which one's taller, which one's been in the league longer? It doesn't matter. Again, it's up to the business to determine what comparison means, and if all your only purpose is to put it into a tree map, then or a tree set, it doesn't even matter what it is if you're not using that sorting for any bigger purpose. So comparison is mostly just a sorting routine. It's what we've looked at it so far, but you can use comparison as some sort of logical mechanism were you so needing, if you truly wanted to sort the object and display them. And you can do multiple sorts as well. So the comparable implementation then is normally, again, very simple. So if I'm going to compare two players, I have in the player class, I implement the comparable interface, which means I have to have the compare to method overridden somewhere in that class or implemented somewhere in that class. And so I compare to another player. Again, normally this class is going to match this class and compare to another player. And so if I'm looking by numbers, I just say which number is bigger. I can take my number and subtract the other player's number. You don't want to add them because that won't work. I can take the other player's number and subtract my number. It just depends on, do you want highest to lowest or lowest to highest? It's just a logic thing instead of there. So in the way we implement it up at top, I sort from lowest to highest. And the way we implement it down below, when I switch player number first, I go from highest to lowest. That's the only rationale that changes inside of this. Which way do we want to sort it as? But in a single number, I can just take that number and compare it to. For strings, I can just say, hey, compare one, string 1 dot compare to string 2. That takes the basic value of a string. So if I want to compare, if I want to compare by last name, I can just do last name dot compare to compare last name, because they're already a comparable implemented. If I want to do by multiples, then I do a little bit differently. So I'm sorry, I just flipped the slide here. So here's an example of compare to, and here's an example of compare to with multiples. So the last name dot compare to the other guy's last name. That sorts them alphabetically A through Z. And if I have multiple comparison, I can say, well, if the last names are equal, then go look at their first names and compare them to each other. And if the first names are equal, then it doesn't matter. They're the same one, possibly. If there's additional things, maybe it's last name, first name, number. Or it could be number, first name, last name. Again, it's the question of, I have to determine both equality and comparison here, because if they're equal, they're going to return a value of 0. So that's the way I go off and can string these together. If the two are equal, 0, I can look at the next field. If they're not, then I order them by that field, and then I can put the fields in whatever order I want to using the appropriate if logic. So which one do you use? Well, a comparable is what you use when I have one and only one way of comparing things, because I'm only sorting internally, and then I can just apply that to the object, and anywhere a comparable is needed, the object is comparable. I don't mind adding the interface, and I only need to worry about one way to sort the objects. I use a comparator when I want to externalize it, in which case when I create the tree set or the tree map, I add the comparator to the constructor, and then I won't use the comparator inside the object. It's going to use it from the comparator externally, in which case then I can have more than one. I can player number comparator, player name comparator, backwards player name comparator, however I want to do that, name number comparator. It's up to you to have multiple logic ways and be able to sort that out. So this is a quick look at using these interfaces. Again, you don't have to do it at all for this week's coding. This week's coding is basically wrapping up the project we had started on, but at least you can see how this is implemented were you so wanting to use tree maps or hash sets or hash maps.